You intend to estimate a population mean with a confidence interval. You believe the population to have a normal distribution. Your sample size is 101. Find the critical value that corresponds to a confidence level of 99%. Report answer accurate to 3 decimal places with appropriate rounding. So we're asked to find a critical value. Because we believe our population to have a normal distribution, we can use a t distribution to make our estimate. And that's where we'll get our critical value from. So let's look at a t curve. It looks very much like a normal curve. More and more so as the degrees of freedom increase. Okay? And we're asked to find the critical value. That's this number right here, this t value right here, that corresponds to having 99% fall between it and its counterpart, because this is a symmetric distribution, its counterpart on the negative end. Well, that leaves 1% for the tails. That means we have 0.5% in that tail. Sorry about that. Erase that. So if we have 1%, we have 0.5% for each tail. Okay. That means that we are looking for the value here for t that puts 99.5% of the area under that t curve to the left of our critical value that I've circled in red. We're going to use the inverse t function on the calculator to do that. So the inverse t will do second and the vars key, which is, in the second function is distributions. And it's the fourth one. You see it says inv t, inverse t function. Okay? And we're going to put in the following inputs. You have to put in the percentage of the curve that you want to the left of your critical value as a decimal. So that's 0.995. And then the second input is the degrees of freedom. Our n is 101, which makes our degrees of freedom 100. And we will hit enter, and then we'll think for a minute for us. And we will get an answer that when we round it, we will get 2.626. So that is our answer. The critical value that corresponds to a confidence level of 99% is 2.626.